we want to determine the convergence of this series, and I see this 2 to the n, so I'm going to try the root test. So I would want to have the limit as n goes to infinity of, and we typically do absolute value, but I can see that both of these are always going to be positive, so I don't have to write that. So I'm going to look at the nth root of 2 to the n over n to the 10. And as I apply that root, I have the limit as n goes to infinity of 2 over n to the 10 over n. So as I think about this, the numerator is fixed, but in the denominator, this base is going to infinity, but this exponent is going to 0. So does this equal infinity? Does it equal 0? Or does it equal somewhere between? Now let's go ahead and just look at this piece and see if we can figure that out. So we're going to look at the limit as n goes to infinity of n to the 10 over n, and we're going to put that equal to y. And then remember a trick we did on these limits like this in Calc 1, we were going to take the natural log of both sides, and I could put that out in front here, but we know it moves inside the limit, so I'm going to write it right there. Now, why we wanted to do that is because then I could take this exponent using properties of logs and I could multiply that out in front. So this will equal the limit as n goes to infinity of 10 over n and then natural log of n. Now as we look at that, and we let n go to infinity, we see that we are going to have infinity for the 10 ln of n, and then we're going to have infinity in the denominator for the over n. So we have an indeterminate form, infinity over infinity, so L'Hopital's rule applies. So I can set this equal to the limit as n goes to infinity of the derivative of 10 ln n, and that's 10 over n, divided by the derivative of n, which is 1. So we can now see as we let n go to infinity that this numerator is going to 0 and 0 over 1, so this limit equals 0. But wait just a minute, that 0 was not for just y, which was the answer to the limit here. It was for the natural log of y. So this equals the natural log of y, and then we could exponentiate both sides to see what y equal, and y equals e to the 0, which is 1. So what that says is, come back up here now, we know the limit of the numerator is 2. The limit as n goes to infinity, the denominator is 1. So our limit is 2, and applying the root test then, if this limit is greater than 1, then this series diverges.